Basically, if you think about where heparin, this blood thinner, comes from, so after you get your pork chops and bacon out of the pig, they scrape the intestine, and the slime inside the intestine is what they actually process to make the drug. Now, it's not that easy to do, but most of the time they can do a good job. But if there's not enough pigs, or if somebody contaminates the supply chain, it's bad news. So they had something like that happen in 2008. So there's a big push on trying to make the heparin in a defined, contained system. So we've been trying to do some of that. It's a big process, and there's other labs around the world that are trying to do it too. We're contributing a small part. But we also have the idea that heparin, besides its ability to be a blood thinner, has anti-cancer or cell growth characteristics, maybe even for some stuff like tissue engineering. So we're trying to keep the heparin under control. So when we give the medicine to somebody, they don't bleed to death. So if it's an anticoagulant blood thinner, you can imagine if you gave too much or it was a side effect, somebody having a hemorrhage is not good. Our lab's main claim to fame is we've discovered the enzymes that build these sugar polymers. So some of those were in our own human body, but it turns out bacteria make sugar polymers too. They do it to camouflage themselves. So you can imagine if you have a bacteria that coats itself with a human-looking polymer, it can be sneaky and escape. So what we've done is we found the enzyme that the bacteria uses and then retooled it and harnessed it in the lab. So we've been supplying this kind of material to researchers around the world and companies, trying to find good uses for these materials. The idea is, can we learn about the body, what it likes and what it doesn't like, and can we then move it on into a therapeutic?